All right, this video clip is going to explain the principle and the functioning of the load track 2 unit here. This is a load track 2, which is a load frame that can be used as load control or displacement control. So you can apply and maintain a load, and the load set here provides a feedback, or you can apply and maintain a constant displacement rate. Now, the first thing you're going to do, you're going to turn it on. And it has an internal CPU that is going to boot, and it's going to check everything here. You get the motor power, the CPU power, the network transmission, network reception. Everything has to be green, solid green on this side for the load frame to function properly. So this is all green, solid green, and I get a menu on the screen here. And so what I'm going to do here, I am going to show you how to move the platen up and down. That's basically all what you're going to be doing with this load frame, moving the platen up and down. All the other options here, you can read those options in the manual. You're never going to have to touch them unless you're going to change something, the motor or the gearing or something like that. And everything here is done through software, so nothing to worry about. The only thing that you have to keep in mind that this standard load frame comes with a 2,500 pound load cell, and all the calibration factors are for this particular load cell that is attached to this load frame. And if for whatever reason, for some special project, you need to change the load frame, a higher or lower capacity load frame, what you do, you just unscrew it here, and I'm not gonna, and take it out, and unscrew it from the back. It connects to the first top connector, and then you can put your new load cell here. Once you change the load cell, then you'll have to change the calibration factor that corresponds to the new load cell. So what I'll do first, I just want to make sure that everything is working. So I go to monitor here. This is when I do it for the first time. I hit 1. Then I got the sub menu here, which is a system. I can see my load, my travel, and some other information about limit switches. So if I push on my load cell like that, I should see about 20 pounds. So that means this is working. If I want to do further check, I can take my load cell, put it on the counter, and put a non-dead weight on it, and it should record that dead weight. The same thing with the displacement sensor here. If I move it up and down, I should see it registering accordingly. If I have a gauge block, I can insert a gauge block here, and it should move exactly the same thickness as my gauge block. Now, this shows limit switches are off. That means I have an upper limit switch and lower limit switch. The total travel of my platen is about 3 inches. That's more than plenty for all your applications. This load frame can test the maximum size triaxial diameter, 6-inch diameter by 12-inch in height. Typically, you take it to 15%. 15% of 12-inch, that's 1.8 inches. So that's a maximum, and we have 3 inches here. So should be plenty of travel that you have. You never have to worry about running out of travel or the displacement is going to max out or anything like that. So if I move my platen all the way up, it will go about 3 inches, hit the upper limit switch, and automatically stop, and I'll have a red blinking light. If I go down, it will do the same thing, and it will hit lower limit switch, and then the red LED will start to blink. Now, if I'm not sure what to do here, and I want to make sure I have enough travel, I will go into position here, and there's something called initialize. When I hit initialize, the platen is going to come down, hit the lower limit switch, and move up. So that gives me the full range. actually recommend that you move the platen up about halfway, so you are in the linear working range of the displacement sensor. Like right here is good. Now, as I said before, this load frame works in load control or displacement control. Load control is when you're doing consolidation, displacement control when you're doing triaxial and unconfined and CBR and other tests that require constant rate of displacement. If I want to move my crosshead here, what I do is I use the locking pins. So I move it up like that. Then I turn it 180 degrees and I take it out. It should come out real easy. And then I can take my positioning pins and I can slide it up or down. Now you notice there is a play here. That's why we have the locking pin that has its own pin here that will take out the play. So again, I put it and I move it 180 degrees and I let it go, and it should be all set now. So now if I want to move the platen up, I go to position, raise, enter. It's going to move all the way up until it hit the upper limit switch. I'm not going to wait here. It's going to take a few minutes. If I go lower, enter, it's going to go all the way down and until it hit limit switch, the lower limit switch. So now if you want to move it, when it moves up and down, you move at the maximum speed. If you want to control the speed, you want to move it very, very slowly. You're going to the jog. So you hit 4. There's an arrow up, an arrow down. So if you want to go up, you hit the arrow up. Now it's going very, very slow. Now if you want to increase the speed, you hit 2 and up. And then you keep on hitting the arrow up. It will go faster, faster. You can even hit 3. And then it's going to hit the maximum speed. Now if you want it to go down, you hit the arrow down. And now it's reversing direction. It goes into a mode, so it starts to make a little music here. Now, if you're using jog, just get out of the jog at the end of that. That's the only menu that we do not might interfere with your test. So what you're doing here is basically raising, lowering, initializing sometimes, and jogging the platen. That's all what you're going to be using the manual option here. So now what I'm going to do, I'm just going to show you whatever I was doing here, I can do it to the computer. So we're going to the computer here, and there is a program called Diagnostics. This diagnostics program, I am going to click on diagnostics, and I have the diagnostic programs. They ask me which controller. That happened to be 65, and the default is 65. I go into view, panel. Now I have the exact panel that I have there, and they correspond, they're the same. So if I do raise, I hit 1, it's going to go up. This is going to change, it's the same thing, and I can go down. If I go to jog, so I can do the same thing. Either I can do it through the computer or I can do it manually with the keypad and the LCD. So this is all what you need to know about using the load frame. You move it up, you move it down, initialize it sometimes, and jog it in and out. All right, the soil that we're going to test in the triaxial typically has a cylindrical shape, and the height to diameter ratio is 2 to 2.5. And this is all coming from the ASTM standard. Now, this soil is obtained from a certain depth from the ground, and typically you know where you have all that information. Then you take this soil and you set it up inside the triaxial cell. You have a bottom cap and a top cap. This is a top cap and the bottom cap that you see here, the black one. So you set the soil sample after you take all the measurements, the weight, the water content, all that information, and then you put the top cap on top. Where else it will go? And then you use a rubber membrane. You want to make sure that is a good one, that doesn't have any holes. You're going to find out when we talk about the triaxial that 90% of the problems running the triaxial are due to leaks. People don't spend a lot of time. They don't check things. This is your rubber membrane. What you're going to do, you're going to isolate the soil from the outside so you can control the outside and the inside. So the membrane is going to go inside this membrane stretcher. With all the experience I have, I've never been able to do this in one hand. So you have a membrane stretcher. So you put the membrane, you do the little vacuum. Remember, I use my mouth here, so next time. So the membrane now is stretched, and then you slide the membrane over, you release this small pressure there, and then you put O-rings on top and bottom. One O-ring on top, one O-ring on top, on the bottom. There's an O-ring groove here. Can you see it? So the O-ring is going to sit in the groove. There's a groove at the bottom too. So you got your sample. We're going to do a full video of that. And so say sample is inside the membrane, and you put the O-ring, and then you snap it, and then you move it down until it fits there. Now you have your sample and you do the same thing. You do the bottom one first, and then the top one. You connect the drainage line that you see inside here, make sure everything is okay, then you run your test on the triaxial. What I'm doing now is I am going to run my triaxial. This video clip is going to deal with running a triaxial test. So I have my triaxial cell here. Obviously, I need to move my my crosshead one notch up. So I center my triaxial cell. So there's a little gap here. I'm going to close that little gap. Not close it totally because the software does it automatically for you. Get as close as I can. My piston is locked. So I am close there. As I said, the software will